Hey, welcome again, physics peeps. We're going to get into projectiles 3. You guys have done other assignments where you have found things like horizontal and vertical speed and range, but now projectiles 3, we are solving for every single one of those things, but it's going through that same process. So we'll try to make this one really quick. So for this assignment, this goes along with number 1, but we have to find all this stuff for a cannon that's fired horizontally to the right off a cliff at a speed of 90 meters per second. The cliff is 4.5 meters high. Ignore air resistance. We need to determine the range, the horizontal speed, and the vertical speed of the cannonball on impact with the ground. So when we do this, it is the same 3 steps that we've done before, and it's really kind of keeping things organized. There's a couple other ways that people keep things organized. I'll point that out here at the end, but it's this setup. And it's keeping track of where things go because many times that information can get mixed around. So here we go. This first step, we split it up, X and Y, halfway across your paper, you vary a Y, you got to keep these things separate. And these equations that we've been using, this stuff, write it at the top of your paper, make sure that you got it. This V equals D over T, and this D equals VI times T plus 1/2 AT squared. And this VF equals VI plus A times T. These equations we can use throughout the problem, and those equations can only be used on certain sides, or you gotta make sure that you're using the correct information on each side. So be very careful when you're setting this up. We split it up X and Y so that we keep that information separate. That's step 1. Step 2, we list out the initial speeds in each direction. So the X, it's horizontal. We imagine like it's going along this horizontal path. Gravity's turned off, and it starts at 90 meters per second horizontally. So its initial speed is 90 meters per second. But vertically, it's not up or down at an angle, so its initial speed is 0 meters per second. That's step 2. And then step 3 is telling what's going on. If it follows this path, gravity is turned off, we imagine that it's moving at a constant speed, so it's constant. And then the vertical speed, that is going to be accelerating. It's not staying constant, but it's accelerating due to gravity. So its acceleration's negative 9.8 meters per second squared. And that's how we start off the problem. Now we can actually go to answer these questions. We need to figure out the range. Remember, range, it is a distance, but it is a horizontal distance. So in order to solve it, we need to solve it on one of these sides. Because it's horizontal, we solve it on the X side. And to use it on the side, it's moving at a constant speed, it's not acceleration or accelerating. So I need an equation that does not have acceleration in it. And it's this top equation. I can use that to solve for the range, equals D over T, and I'm going to solve for this D, which means I put stuff in where it belongs, like the 90 meters per second, that goes in for the V. Because it's moving at a constant speed, that's always going to be its V horizontally. And then I leave D because I'm going to solve for it, but then the time, nuts, they did not tell us the time, so I need to go over here to this side to solve it out. Make sure you're copying this down as you go, and it's kind of that same groove as before, but hold tight because it's going to change up here in just a little bit. But you got to show your work when you do this. You got to show your work. And then over here on this side, I need to solve out for that time, but I need an equation that has acceleration in it because it's accelerating. So I can choose from one of these two. Remember, it's the second one that we can use to solve for time. This VI times T plus 1/2 AT squared. Because it has everything that I know. I know the height that it's actually dropping from. It's a vertical height, so I can put that in on this vertical side. It's 4.5 meters high, but we write it as negative 4.5 because it's dropping 4.5. Equals the initial speed, it is not 90, it is 0, times t. That's what we're going to try to solve for. Plus 1/2 times the acceleration times the time. But don't forget the squared. Don't forget the squared. The acceleration is negative 9.8 because we listed it out that way. And now I'm going to simplify things to solve for that time. I can cross out the 0 times t. This side remains negative 4.5. And then I have 1/2 times negative 9.8. I type that on my calculator. I get negative 4.9. Sweet. Times t squared. I can't forget that squared. But now to undo this, I need to get t by itself. I have to undo negative 4.9. Remember, it's not add negative 4.9. I have to divide by negative 4.9, both sides. So, oops, that's a 5. Negative 4.9. The negative 4.9 goes away on that side, and negative 4.5, oh boy, comes out to be 0.92 equals t squared. Remember, that's not t, that's t squared. So now I have to undo the square. And I undo that by taking the square root, both sides. And in this case, it comes out to be that t equals 0.96. That's my time. So if you remember from last time, we take that time. We came over here and did all this work. This isn't actually an answer for what we need. We need to take that and bring it back over to this side and put in 0.96 into our equation for time. So now to solve for d, I have to multiply these two things together because I have to multiply by 0.96 on both sides. And that distance, it comes out to be times 90. 86.25. And if your number comes out a little different when you round it, that's okay. Rounding is kind of, I kept this on my calculator the whole way through. And so if I was doing the rounding, my answer does come out to be a little bit different. That's okay as long as you're in the ballpark. Like if you're getting 86.4, that's great. If you're getting like 85.9, that's fine too. As long as you're in the ballpark. Because I solve for distance, it is meters. But here's the thing, is that you need to know what this actually stands for. This actually solves for my range. It's my horizontal distance. We label this dx, but you need to know that this is your range, 86.25 meters. Huzzah. And so we're not done yet because now we have two other parts to this question. And this is where it gets really messy. First, making sure that you have things separated out, that you showed your work, and the more organized it is, the easier it is for you. Your work isn't for me, it's for you. Okay? But things to keep in mind. Show your work. Writing the equations is helpful. When you get stuck, go back to write the whole equation out and try to put stuff in, because that's where people get a little stuck. Make sure that you call this distance negative because it's dropping that far. But also, when you are doing these steps, it's don't cut out this stuff where the work is, because this is what's guiding you. And you'll see that over the next couple problems. Because things are going to change up. It's not a canon that you're going to be using anymore. And it'll change up a little bit, but you'll kind of see once you make the change up, if you show your work, you can follow things through. And don't forget the square, those kinds of things. But if you have this, that's awesome. Box your answer, you're good. Now when we go to answer these two pieces, we could actually do it. It's actually not that bad. It says determine the horizontal speed of the cannonball on impact with the ground. The horizontal speed, nets, horizontal. Oh, horizontal, I have to solve for that on a certain side of the problem. It's on the horizontal side. It's on the x side. But remember that we wrote it down. It starts at 90 meters per second. It's moving at a constant speed. Well, hot diggity dang. My horizontal speed is just equal to 90 meters per second. So I label it Vx. I didn't have to do an equation for it. I can just write 90 meters per second for this answer. Yay! But now it says determine the vertical speed of the cannonball on impact with the ground. So the vertical speed, it is not 0, it's accelerating. And to figure out that vertical speed, I can use this equation, this bottom one. Because it's accelerating, I can use it to solve out for that speed after a certain amount of time. So I now have kind of like a new thing that I'm doing also on this side. But I have to solve it out on this side. Don't mix things around. If you're solving for something vertical, put it on the vertical side. When people try to solve for it over here, there's things that tend to happen. I'll show you. But if I solve for it here, VF equals VI plus A times T. My VI, it's 0. It's not 90. When people solve for that equation on this side, they put 90. Don't do it. Don't let your friends do it. Solve for it on this side because your eye will look at this and it will say 0. And that's why you wrote it there. Plus the acceleration. The acceleration is the exact same thing that we had as before for acceleration. It's negative 9.8 times the time, and the time. Nuts. They didn't give us the time, but wait, I actually solved for it right here. That time I can use on both sides. So not only could I use it to get over here, I can just swing it back over here and put in 0.96 for the seconds. And now I can use that to solve it out. So 0.96 times negative 9.8, you end up with negative 9.41 meters per second because I solved out for a velocity. But this is my vertical velocity, so I label it Vy. And so I can write my answer 9.41 meters per second. Huzzah. And these problems just get complex in how much that there is as you're going through. And just keep in mind that we set this up with those 3 steps, separate out x and y, write out your initial velocities, write out what's happening, because it guides you on what equations to choose. You can kind of, once you kind of do a bunch of these, you kind of get into that groove, and that's fine. But you want to make sure that this equation, sometimes it gets put over here. Don't put it over on the horizontal side. This equation belongs on this side because it's accelerating. Also, notice that you don't have to solve everything out in the same order. We could actually say this Vx was 90 meters per second right off the bat. But to solve out for our range and solve out for this, we did need to figure out the time. And so sometimes solving out for the range first, that's really useful. Okay? But check what you're given, make sure that you know what you're doing with it. And then if you get stuck, go back to writing out the equation. You'll be good. And try it out. That's the first problem. Your other problems, they are a little different, and that's okay. You'll do great. All right? See you guys.